Hi friends, in today's video, we are solving an exponential equation 3 to the power of x plus 9 to the power of x equals 27 to the power of x. First, let me rewrite the equation as follows. See, the base figure is a power of 3. So I'm rewriting like this. In the next step, let me interchange positions of 2 and x this way. This is done on the basis of this law of index. Now let me substitute where y is equal to 3 to the power of x. Then this equation will change to y plus y square equal to y cubed. Now look at this y, this new variable brought in, which is equal to 3 to the power of x. This 3 to the power of x is a non-zero positive number. The reason is this: even if you choose x as negative, for example, say let x be minus 2, y will be what? Y equal to 3 to the power of minus 2, which is 1 by 3 squared. Look at this number. It is clearly a positive number and it's a non-zero number. Can you see that? The point I'm trying to convey is y is a positive non-zero number. Okay, so let me divide this equation. You may call this equation 1. Dividing equation number 1 by y, which is clearly a non-zero positive number, you will have y by y square divided by y equal to y cubed divided by y. Division by y is perfectly valid because y is a non-zero number. It works in all cases. Now simplify this. Y divided by y, 1. Y square divided by y, just y. And the right side will be y squared. Now do one thing. Take 1 plus y to the right side. You will have, let me write y square first. Plus y becomes minus y. Plus 1 becomes minus 1. And you will have 0. Now this is a quadratic equation in y. So let us solve this equation using the formula method. See, the solutions of a quadratic equation like ax square plus bx plus c equal to are given by this formula: minus b plus or minus square root of b squared minus 4ac the whole divided by 2a. The general result. Compare this to the quadratic we have. Here a equal to 1. A is the coefficient of y squared. Then b is what? The coefficient of y, which is minus 1. And the constant term is again minus 1. So the roots of this quadratic equation y equal to minus b, which is minus 1, plus or minus square root of b squared, which is minus 1 the whole square, minus 4 multiplied by 1, then c is minus 1, the whole divided by 2 multiplied by 1. Now this on simplification, minus will be plus or minus square root of minus 1 the whole square is plus 1. Then this minus and this minus will be plus. So on simplification, under the root sign, you will get just 5 divided by 2. So we got the two solutions for the variable y. But y is a dummy variable we had brought in. The actual value of y is equal to 3 to the power x, which implies 3 to the power of x equal to 1 plus root 5 by 2. That is one value. The other value, 1 minus root 5 divided by 2. These are the two values of 3 to the power x. Now, like I discussed before, 3 to the power x, whatever be the values of x, is a non-zero number and it's also positive. That implies 3 to the power of x cannot be this one, 1 minus, because see, 1 minus root 5 by 2 is a negative number. Since root 5 is greater than 1, this on simplification will turn out to be negative, whereas this is positive. This value is not acceptable because of 3 to the power of x being a positive non-zero number. So we will reject this. So the only value of 3 to the power of x is equal to 1 plus root 5 divided by 2. Now how do you bring 3 to the other side? We are solving finally for x. You need to bring 3 to the right side. Using the fundamental definition of logarithm. As you know, logarithm is the inverse operation of exponentiation. So x will be, when 3 is taken to the right side, it goes like this. Log 1 plus root 5 divided by 2 to the base 3. This is the value of x. There are other ways to come to this step from this step, taking logarithm on both sides and stuff like that, which involves 4-5 steps to be written unnecessarily. Instead, if you know the correct definition of logarithm, this is the way it goes. So you can straight away write this from this step. And the final solution of the equation, see, this was the equation we had. 3 to the power of x plus 9 to the power of x equal to 27 to the power of x. And this is the solution for this equation. Now, as you know, it's possible to verify whether the solution we have found out is correct. What do you do for that? Just plug in the value of x in the given equation and simplify both sides. You should get the same number. Yeah, we will do the verification part also. To verify, plug in x equal to this, that is logarithm of 1 plus root 5, the whole divided by 2 to the base 3 in the given equation. This is what you get. 3 to the power of log 1 plus root 5, the whole divided by 2 to the base 3 plus 9 log 1 plus root 5 divided by 2 to the base 3. I'm taking the left hand side. Let me simplify the left side separately first. Then we will take the right side and simplify. Here we will use one rule in logarithm. A to the power log b to the base a equal to b. So comparing this to this, instead of b we have 1 plus root 5 divided by 2 and a is 3 and the whole thing is just b. So what do you have? 1 plus root 5 divided by 2. This is the first term. Now the second term I'll do separately and substitute here. 9 to the power of log 1 plus root 5 divided by 2 to the base 3. Here these two numbers are not the same, but you can modify it this way. 9 is just 3 to the power of 2. So you will have this divided by 2, 3. And this is equal to, see, using power rule in logarithm, this 2 will go up. 1 plus root 5 divided by 2, the whole square to the base 3. We have made use of this power rule in logarithm. That is log a to the power of m equal to m log a. Now this is exactly in this form. The b will be 1 plus root 5 divided by 2, the whole squared. So that will just be this, the whole squared. So we have simplified the second term of the left side into this, and let me substitute that here. Now let me bring down this term and further simplify. 1 plus root 5 divided by 2 plus, let me expand this. That will be a plus b the whole square, 1 squared plus root 5 the whole square plus 2 multiplied by 1 multiplied by root 5. This is the 2ab. A square plus b square plus 2ab. The whole divided by squaring 2 you have 4. Now let me further simplify. To change this denominator into 4, let me multiply both the numerator and denominator by 2. So you will have in the numerator 2 multiplied by 1 plus root 5. Again, you are multiplying denominator also by 2. So you will have 2 multiplied by 2. Let me write it as 4. Okay. And cutting short one step. Plus 1 square is 1. Root 5 the whole square. That is just 5. This is 2 root 5. The whole divided by 4. Which is equal to, this is 2 multiplied by 1. 2 multiplied by root 5, 2 root 5. Same denominator. So you can combine these two. 1 plus 5, 6. Again 2 root 5. The whole divided by 4. 6 plus 2, 8. 2 root 5, 4 root 5 divided by 4. Now dividing each of these terms by 4, you will have 2 plus root 5. So this is the left side. Okay. Now let me take the right side, which is 27 to the power of x, and do this process again. Yeah, the right side was 27 to the power of x, which is equal to 27. X we had found out to be, yeah, we have already done that substitution. X is 1 plus root 5 divided by 2 to the base 3. This is equal to 3 to the power 3. 27 is 3 to the power of 3. Then log 1 plus root 5 divided by 2 to the base 3. Now using the rule of logarithm discussed before, you may please refer back. This can be written as 3. Yeah, before applying that rule, you take 3 to the power of this thing using the power rule. So you have 3 to the power of log 1 plus root 5 divided by 2. This 3 will go up as power. Okay, to the base 3. This is just 1 plus root 5 divided by 2, the whole to the power of 3. This will be 1 plus root 5 cubed by 2 cubed. Now we will use the idea of a plus b the whole cubed, which is a plus b the whole cubed equal to a cubed plus b cubed plus 3a square b plus 3ab square. Using this in the numerator here, you will have 1 cubed plus root 5 the whole cubed plus 3a square. That is 1 square multiplied by b. B is root 5 plus the last term 3a, which is 1 multiplied by root 5 the whole square, that is b square. The whole divided by 2 cubed, which is 8. Now 1 cubed is 1. Root 5 the whole cubed will be 5 root 5, and this term will be 3 root 5 plus root 5 the whole square will be 5. That 5 multiplied by 3, 15, and the whole divided by 8. You might want to know how I wrote root 5 the whole cubed as 5 root 5. I'll show it here. Root 5 cubed will be root 5. Combining these two, what do you have? 5. The other root 5 I'm writing. That's how I wrote this from this. Okay. Now this you further simplify. 1 plus 15, that is 16. 5 root 5 plus 3 root 5, 8 root 5, the whole divided by 8. Now you separately divide these two terms by 8. So 16 divided by 8, 8 root 5 divided by 8 will cancel out and you will have root 5. See, you refer back. This is what we had by simplifying the left side. Rather, both the sides of equation on plugging the value of x have been simplified to the same number, showing what the solution we had found out was correct. The solution is pretty lengthy because of the verification part which I have done in this problem, and we had used some results radicals also while verifying the solution. So if there is any point you are not so clear about, please leave your remarks in the comments below. And if you think my channel is helping you, please help me grow this channel by subscribing to the channel and sharing it with others who you think might benefit from this. Also, please hit the like button and also the bell icon. Thanks for watching and see you in the next video.